Hello, learners. Today we see about one interesting topic that is that is azeotropes. What is azeotrope? Azeotrope is a special mixture of two or more liquids, and it behaves like a single substance and which displays the same level of concentration in liquid and vapor phase. So it boils at the constant temperature, and vapor also has the same composition of liquid. So it cannot be separated by normal separation. So simple distillation cannot alter their properties. And the azeotropic mixture is also called as what? Constant boiling mixtures. Because it boils at constant temperature and the vapor has the same composition of the liquid. That's why we cannot separate using the normal distillation process. For rectifying this problem, we move to the one distillation process that is called as the azeotrope distillation. Because in regular mixture, the more volatile liquid boils off first. But in azeotrope, the mixture boils as where one pure substance. So components don't separate. So for that problem, we add a third component which change the volatility of one of the two components more than the other. So the components separate by using the distillation. What are the significance of azeotrope? They cannot separated by fractional distillation. It indicates separate methods have to be adopted to obtain one of the components in pure state. Then we move to the azeotrope distillation production of 100 percentages of alcohol. Because the alcohol had ethyl alcohol and water that containing 95.6 percentage alcohol and remaining water. It's called as the what? Rectified spirit. For that the separation of 100% alcohol, we added to the mixture one solution that's called benzene. So the mixture is kept to that 337.6 Kelvin, a ternary azeotrope mixture that contains benzene, water, and alcohol. At 340.8 Kelvin, the binary azeotropic mixture of alcohol and benzene distills. So the flask containing 100 percentage of ethanol, which distills at 351.2 Kelvin. Thus, we get pure alcohol. In this way, we break the azeotropes by adding third component. So, So we get a clear idea about the azeotropes. It's a special mixture of two or more liquids behave like a single substances. So it's boiled at the constant temperature and the vapor has the same composition. So we cannot separate by using the normal distillation process. For that we add the another third substances and then it's distilled by using the azeotrope distillation method. And the azeotropes are divided into two types, that is minimum boiling azeotropes and maximum boiling azeotropes. First type, minimum boiling azeotrope, the liquid which shows the positive deviation from ideal solution and boil at the constant temperature which is less than the pure component is called as the minimum azeotropes. For example, water boils at 100 degrees Celsius. Ethanol boils at 78 degrees Celsius. When the composition of ethanol plus water is boiled at 78 degrees Celsius. So it indicates that it's the solution boils at lower boiling point than its constituents. So ethanol plus water is best example for the minimum boiling azeotropes mixtures. Then maximum boiling azeotropes, the liquids which shows negative deviation, that means higher than that of the pure components boiling points, it's called as the maximum boiling azeotropes. For example, water boils at 100 degrees Celsius, hydrochloric acid boils at 84 degrees Celsius, but the azeotropic mixture of water and hydrochloric mixture added and boils at around 110 degrees Celsius. It indicates higher than that of the boiling point of original constituent mixture like water and hydrochloric acid. So it's higher than that of the both components. So hydrochloric acid and water has the best example for maximum boiling azeotropes mixture. Yes, finally we are getting idea about the azeotropes. and what is azeotrope distillation and what are the types of azeotropes. Okay, tomorrow we see the another important topic. Thank you. Thank you for watching.